Alright, now let's look at this question. This is all about machine learning algorithm. Option A says latent dirichlet allocation known as LDA. LDA is designed for topic modeling and text, not for image based classification. Incorrect. If you want the PDF version including the keyword tricks, please enroll in Diamond membership or above by clicking the join button. Please select the Diamond tab there, then proceed with it. And after you're done enrolling in membership, please do connect with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique. I'll be happy to help you with the hands-on files as well as the PDF files. We'll move to B. B says recurrent neural network known as RNN. RNN are suited for sequential data like time series or language, not static image classification. We'll delete it. We'll move to option C. C says K-means performs unsupervised clustering and lacks the capability to learn brand specific visual features. What we need wearing the company's branded apparel, right? So this is out. We are left with option D, that is convolutional neural network, CNN. CNN excels at extracting spatial features from images, making it perfect for brand detection in visual data. We'll lock convolutional neural network CNN as a right answer. Alright, now let's look at this question. Option A says launch the training job in SageMaker script mode using the existing train.py script and point to a local data path without changing the TF record format. Local path usage requires custom container setup and doesn't scale well for distributed training. Incorrect. We'll move to now option B. B says use SageMaker script mode with the current train.py and reference TFR record data stored in Amazon S3 bucket without reformatting. SageMaker script mode in S3 supports direct use of existing script and data format with minimal setup, that is least development overhead and no code changes. That's what is required. Let's keep it. We'll move to option C. C says modify the train.py script to convert TF records into photo buff format and ingest the new format during training. Rewriting the script to convert formats adds unnecessary development effort. Wrong answer. We'll move to option D. D says use glue or lambda to reformat the TF record data and store it in S3 in a format compatible with SageMaker. Reformatting data introduces extra processing steps and changes the original format, which will increase complexity or development overhead. We'll delete this. Lock option B as the right answer. Let's bring the heat to the snow. This will test your concepts where sites lack high internet speed, where the company requires near real-time inference capabilities. Option A says host the model in SageMaker and stream sensor data to it for maintenance prediction. SageMaker hosted model relies on stable internet, which is unavailable at many factory sites. So this is incorrect. Now let's move to option B. Option B says deploy the model locally in each factory using AWS IoT Greengrass to perform maintenance inference on site. AWS IoT Greengrass in each factory supports local inference with low latency and minimal dependencies on internet connectivity. Let's keep it. Let's move to option C. C says use SageMaker batch transform to run daily jobs that identify machines needing service. SageMaker batch transform delivers delayed insights, which is unsuitable for near real-time maintenance. Wrong answer. We'll now move to option D. D says host the model in SageMaker, route sensor data via IoT rules to DynamoDB and trigger inference using AWS Lambda. Streaming through DynamoDB and lambda will add network dependency and latency, which we definitely don't want as per the scenario, and is definitely unsuitable for low connectivity environments like what we have as per the question. So this cannot meet the requirement. D is out. We'll lock option B as the right answer. Okay, we got a brainstorming question where we got to detect the V type and location. So which modeling approach is the best for this use case? Option A, if we look, image classification identifies V types, but the problem is it cannot provide location coordinates. That is the another requirement of the question. Therefore, A is out. We'll move to now B. B says convert the image dataset into Parquet format and store it in S3. Apache Parquet is not a supported format for image input in SageMaker object detection. Wrong answer. Let's move to option C. Option C, if you look, SSD algorithm with record IO format supports both read classification, that is read type, and bounding box localization, that is location detection, aligning with the requirement of the question, the need to detect type and position or location. Let's keep it. We'll move to now option D. Option D, again it uses Parquet, which just like option B is definitely out, and also image classification, if you look, lacks the spatial detection, and Parquet will definitely add compatibility issues as mentioned before. So D is out. Option C is the right answer. Okay, let's now look at this question. We'll look at first option A. Option A, if we look, separate endpoints with application logic require custom routing code and will increase definitely operational overhead, that is will increase engineering effort in some way. A is wrong. We'll move to now option B. Option B, if you look, production variants enable traffic weighted routing across models with minimal setup and support long-term parallel evolution. Let's keep it. We'll move to now option C. Option C, if you look, SageMaker Neo focuses on model optimization for edge devices, not traffic control for parallel evolution. Wrong choice. Now let's look at option D. Option D, if you look, batch transform is designed for offline inference, not real-time traffic management. Hence, incorrect. We'll lock option B as the right answer. Alright, now let's look at this question. Option A says apply supervised classification to predict monthly categories outcomes using available claim content. Supervised classification using claim content predicts category labels, not future volume trends over time. Incorrect. We'll move to B. B says use reinforcement learning with claim IDs. Reinforcement learning with timestamps lack a reward structure and is unsuitable for volume prediction across time intervals. Therefore, wrong answer. We'll move to now C. C says use time series forecasting with claim ID and timestamps to estimate monthly claim volumes per category. Time series forecasting aligns with the goal of predicting future monthly volumes across categories using historical patterns. Let's keep it. We'll move to option D. D says combine supervised classification for categories with partial claim content and time series forecasting for the remaining categories. Hybrid classification and forecasting adds unnecessary complexity without improving accuracy for volume prediction. We'll eliminate it. We'll lock option C as the right answer. Alrighty, we have a brainstorming question. Let's first look at option A. Option A uses Lambda with SageMaker, which will add latency and doesn't adapt dynamically to streaming changes, which is the requirement here. Therefore, wrong answer. Let's move to option B. B says train an anomaly detection model using Amazon SageMaker's XG boost algorithm on historical traffic data. XGBoost is not designed for unsupervised anomaly scoring on unlabeled data. So this is out. We'll move to C. C, if you look, uses KNN SQL extension to assign an anomaly scores in real time. KNN lacks native support for evolving pattern detection in streaming data. Therefore, wrong answer. We'll now move to option D. Option D, if you look at RCF, that is random cut forest SQL extension and sliding window, supports real-time scoring and adapts to evolving traffic patterns using streaming native anomaly detection. That being said, option D is the right answer. Okay, so this here we have some mathematical calculations, which is about Naive Bayesian model or full Bayesian network. We have some Pearson correlation coefficients as well here. Option A says choose a Naive Bayesian model assuming all features are conditionally independent. A Naive Bayesian model contradicts observed correlations which indicate feature dependence. Incorrect. We'll move to now B. B says choose a full Bayesian network assuming all features are conditionally independent. Full Bayesian networks are not suitable when assuming independence across features. Will eliminate it. Now let's move to option C. C says choose a Naive Bayesian model even though some features are statistically dependent. Naive Bayesian models doesn't model dependencies, making them unsuitable when features are correlated. Wrong answer. We'll move to now option D. D says choose a full Bayesian network because some features are statistically dependent. Full Bayesian network captures inter-feature dependencies aligning with observed correlation values. That being said, option D is the right answer. Okay, now let's look at this question. This is all about mathematical calculation, I'll say. Option C says 3 shards. 3 shards only supports 3 MB per second, far beyond the required 30 MB per second. Therefore, wrong answer. Option B says 30 shards. So here each shard supports 1 MB per second as mentioned. So 100 kilobyte into 30 TPS equal to 30 MB per second, requiring 30 shards. Looks good, we'll keep it. We'll move to now C. C says 300 shards. 300 shards will definitely exceed the required capacity by a factor of 10, leading to unnecessary cost. Wrong answer. And same goes for option D. Since 300 cannot suffice, so 3000 definitely is too much. Like it's massive thing which we do not require, and it will include in additional cost which we don't want. D is out. We'll lock option B, 30 shards, as the right answer. Alright, now let's look at this question. This is all about fastest route to index the assets. Option A is leverage recognition for image and video tagging, Amazon Comprehend for text analysis, and Transcribe for audio transcription to automatically classify content. Recognition, Comprehend, and Transcribe are pre-trained services that automate multimedia tagging with minimal setup and fast turnaround. Looks good, we can keep it. Option B says design human intelligence task using Mechanical Turk to manually label all multimedia files. If you look here, the word manual labeling through Mechanical Turk is time intensive, because any manual work in production environment or any environment will take time, right? And even prone to human error, which we don't want. And also this solution doesn't scale efficiently. So option B is wrong. Now let's move to option C. C says use Transcribe to convert audio to text, then apply SageMaker's neural topic model and object detection algorithms to categorize the content. Using SageMaker's NTM model requires training and tuning, which will add development overhead. This is out. Now let's move to option D. D says build custom models for transcription topic modeling and object detection using AWS Deep Learning EMI on Amazon EC2 GPU instances. Deep Learning EMI demands custom model development and infrastructure management, delaying deployment. Wrong answer. Will lock option A as the right answer. So please don't go away. Let's meet in next part of the series. If you want the PDF version including the keyword tricks, please enroll in Diamond membership or above by clicking the join button. Please select the Diamond tab there, then proceed with it. And after you're done enrolling in membership, please do connect with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique. I'll be happy to help you with the hands-on files as well as the PDF files.